Hello, and welcome to the midterm review for winter 23. And we are starting with question number one. Your question number one will be this question. I had to do some reordering. So it says the pie chart below shows categories of federal spending. It was the planned spending for 2011 to 2020. What is the single greatest expense category that they had planned? And so looking here at the pie chart, it looks like Medicare and Medicaid at 23%. If the government expects to spend $2.5 trillion, that's what it looks like. How much money will be spent on this greatest expense category? So that means we're taking 0.23 times $2 trillion. And that should be equal to 5.75 times 10 to the 11th. So 23% of $2.5 trillion should be 5 billion, 5.75 billion. Okay, let's look at question number two. Question number two is this dot plot that kind of looks like a histogram. And it says the dot plot below shows the number of televisions owned by each family on a city block. These are discrete data because they could have 0 TVs all the way through 8 TVs. Which of the following statements are true? The distribution is skewed right with no outliers. The distribution is right skewed with 1 outlier. The distribution is left skewed with no outliers. The distribution is left skewed with 1 outlier, or the distribution is symmetric. So if it were left skewed, the extra data points would be to the left. So we know it's not C or D. Okay. So we could do a couple things. We could put this data in Desmos, actually, which I think is a great thing because many of you are still struggling with the concept of the weighted average. And we are going to do what is called a weighted average for this. So I'm going to share my screen here. And make a table. And in X1, I'm going to put the outcomes, so the number of TVs possible. And then in Y1, I'm going to put the data. So there was one household that had 0 TVs. There were 3 households that had 1 TV. 5, 4, 3, 2, 1. Whoops. 3, 2, 1, 1, 1. 1. Okay. So we can then find the weighted average. So we can find the mean by taking the total of X1 star Y1 and dividing by the total of the Y1. And so the mean of this data is at 3.238. Okay. Now we can also find the standard deviation of this data. So if we do the square root of, let's see, the deviation. So this would be the outcomes of X1 minus the mean, which is 3.238. And we square that and divide by, oops, no, should be, it was in there, divide by the total of the Y1s. Sorry, I had a little video glitch there. So this is our standard deviation. It's the total of the deviations squared times the number of frequencies of each of those deviations. And then divided by the total of the observations, the frequencies in Y1. And the square root of that gives us the standard deviation. So the standard deviation is 2.02. So if we want to see, we've learned that if it's symmetric, if we're going to use the mean, then we should be able to take the mean of 3.238 and add 2 of those standard deviations. And any observation that is bigger than that would be considered unusual. And so anything bigger than 7.28. So technically this one is the only outlier. So it looks like B is, the distribution is right skewed with one outlier. And we could actually look at the median and see what that is as well. So the median would be, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So N is 21. Okay, so the very middle one would be the 11th. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 3 is the median. So it's actually pretty symmetric. This is a good thinking question. I would not put one kind of crazy like this on the midterm, but it's a good thinking question. Okay, question number 3. In July of 2005, the Gallup organization polled 489 adult Americans to estimate the proportion who believe that smoking in this country should be made totally illegal. The survey found that 16% of the respondents in the sample thought smoking should be illegal. So we learned early on in the semester about the population in the sample. The population is everyone we want to learn about. So we don't want to just learn about the smokers. We don't want to learn about just this. They're actually estimating the people that feel like it should be illegal. So it's not just people that are voters. We really are asking all adult Americans, how do they feel about smoking and being illegal? So describe the sample for this study. So they actually sampled 480 adult Americans. So it was be the 489 adult Americans. Identify the statistic reported in this study. And that would be, the statistic is the 16% who want smoking illegal. Explain why we do not know the exact value of the parameters. So the parameter comes from the population. And that would be the percentage of everyone, all adult Americans in the population that believe smoking should be illegal. But we don't have that data. So we only have sample data. Question number 4. Match each description with the corresponding histogram of the situation. So these are good thinking problems as well. So whatever this distribution is, the outcomes are fairly equal. And there looks like to be 6 outcomes, right? 6 different outcomes. Whatever this distribution is, it looks to be skewed left. And the majority of the outcomes are over here to the right. And it looks like there's about 6 outcomes as well. And then the distribution here in letter C, there's many more outcomes, maybe 10 to 20 outcomes. And it seems to be skewed right, a big kind of center here, and then kind of an equal amount over here to the right. So let's read our options. The first option is the age of death of a sample of 19 typical women in the U.S. Okay. The second one is a fair 6-sided die is rolled 1,000 times and the results of each are recorded. And the third is the ages of 1,000 random people at the opening weekend of a new action movie. Okay. So the one with the 6-sided die should technically have approximately equal outcomes. So that's going to be A. Now, the age of death of a sample of 19 typical women in the U.S. The sample size is fairly small, so I'm leaning towards B. And it's not likely that you're going to have a lot that die young. The majority are going to hopefully be in this older group. So I would say that is B. And then the age of 1,000 random people at the opening weekend of a new action movie. So there's a lot of outcomes because it's ages. The ages are going to vary. It's an action movie. So it could be, you know, younger teenagers all the way through elderly people. And I would say the majority would be probably in their 90s or 20s in this area. So that would be letter C. Catch me back for more of the review.